Hi everyone, I'm going to be going over question 30 from the chapter 6 bingo problems. And this question has to deal with a block of ice sliding down a ramp at 36.9 degrees below horizontal, and the distance it goes is 1.35 meters. And what this question wants to know is how fast the block of ice is going at the end of the 1.35 meters. And so what we need to do is we need to use the force equals mass times acceleration, and that's where this came from, derived from the F equals ma. Kind of went crazy a little bit when I was writing all this preparatory stuff down, so I already started getting into this, but we're just manipulating the equations that we use all the time for force. Also, we'll be using this kinematic equation where the squared final velocity equals the squared initial velocity plus 2 times the acceleration times the distance or displacement. So we have this right here, and now we can cancel out the mass since it happened on both sides. So we end up with the acceleration equaling g sine theta, which is perfect because now we can plug this into our kinematics. So we'll get v f squared equals v I squared. Now, like I said, we want to solve for the final velocity, and so what we can do now is we can plug everything in that we have just to make it easy on ourselves, and we'll end up with the final velocity, which we don't know. The initial velocity is 0, so 0 squared is just 0 plus 2 times gravity, 9.81, sine of 36.9 degrees times that displacement that this block is moving, which is 1.35 meters. So now that we have all of this, we also need to take the square root. So end up all of that. So 0 squared plus 2 times 9.81 sine. And when we throw that into our calculator, we end up that the final velocity ends up being just about 4 meters per second. So just to kind of recap everything, we combined kinematics with our force equation. We manipulated both of them really to be able to use that angle that we have, which is why we brought the sine theta in so that we could account for the angle. We had our displacement, and we were able to figure out what that final velocity was. So I hope you learned something, and I'll see you in the next video.